Welcome back to topic 29, rational exponents. This is part 4. So this is going to be the bottom portion of your foldable. We're going to start with the bottom cover. So notice here how we're going to start with the nth root of b raised to the nth power. Now this is the same thing as b to the 1/nth power raised to the mth power. And that's because under your radical here, this is really b to the first. So that's where their 1/n comes from. Now using the properties of exponents, we have a power raised to a power, we can multiply that, which gets us b to the m/n. So we're going to do a few examples just like we did for part 3. The square root of b cubed, or b to the 3/2, is the same thing if we have the example square root of 9 cubed. And that's the same thing as 9 to the 3/2. So notice here, if we want to do our chocolate bar method, we can do our first chocolate bar would be divided into 2 spots, and we get 9. So multiplying together, we would get 3 times 3 gives us 9. But notice here how instead of 2 pieces, we want to take 3. So we need to draw another chocolate bar. Which will also give us 9. So instead of just taking these 2 sections, we need to take 3 sections altogether, which would be 3 times 3 times 3, which would give us 27. So whenever you have an exponent that is greater than 1, 3/2 is greater than 1, your answer is going to be bigger than your base because 27 is greater than 9. Let's go to the next example. Cube root of b raised to the 2nd power, or cube root of b squared, is the same thing as b to the 2/3 power. Let's try cube root of 64 to the 2nd power. This is the same thing as 64 to the 2/3 power. Notice here how your exponent is less than 1, so our answer will be less than our base. So here we can do the chocolate bar method. We can also look at this as 64 to the 1/3 and then squared. So what's the third root of 64? What's the cube root? That would be 4. Then we can take 4 and square it and get 16. So we're thinking about PEMDAS here. We're working from the inside out using our parentheses and exponents. Next example, cube root of b raised to the 4th power, or b to the 4/3. Let's do the cube root of 8 raised to the 4/3 power. Raised to the 4th power, which gets us 8 to the 4/3 power. So here, we know because our exponent is greater than 1, our answer will be bigger than our base. So we're going to have 8 to the 1/3 power raised to the 4th. 8 to the 1/3 power, the cube root of 8 is 2, raised to the 4th, also gives us 16. Okay, what about the 4th root of b raised to the 3rd power, or cubed? So that's b to the 3/4. Let's try the 4th root of 16 cubed. So that's the same thing as 16 to the 3/4. So we know that 16 to the 1/4 is 2. 2 cubed is 2 times 2 times 2, which is 8. Last example. 5th root of b squared, b to the 2/5. Let's do the 5th root of 32 squared. So that's the same thing as 32 to the 2/5. So 32 to the 1/5 and then squared is the same thing as a number times itself again, times itself again, times itself again, which would be 2 in order to get to 32. 2 squared gives us 4. So let's open up that flap to get the examples underneath. We're going to start with translating expressions in radical and exponential form. Our first example, we need to translate into radical form because it's already written in exponential form. So here we have 14 to the 3 halves. We can rewrite this in radical form. We know this 2 is going to be our root. So we want the square root of 14 cubed. And a lot of this is just getting practice with translating back and forth. Notice how I wrote the 2 in the root here. You don't normally have to do this. I'm just doing it for example purposes. If you feel comfortable by knowing that the square root automatically has a root of 2 in it, you can leave it out. You can omit it. Next, we have 5x to the 3 halves. Notice here how the x is the only thing raised to the 3 halves. So our 5 is going to be on the outside. Get it out of there. Then we have x to the 3 halves. So that's the same thing as the square root of x cubed. Similarly here with 17y to the 2/3, our 17 is going to be outside. Then we're going to have the third root of y squared. Notice how here these two variables are completely different, x to the 3 halves and y to the 2/3. Even though they have the same numbers, it's because their fractions are reciprocals of each other that we get 2 different roots. Next example, x to the 4/3 power. So this is the same thing as the third root of x raised to the 4th power. 19ab to the 5 halves. This 19a is not attached to an exponent other than 1. So we're going to leave it outside. And the b, that's really the square root of b raised to the 5th power. 4th root of y cubed. That's the same thing if we want to write it in exponential form as y to the 3/4. 12n, the square root of 12n cubed. Since this entire quantity is the square root, that means when we write our answer, I'm going to have this entire thing be in parentheses here. And that's the same thing as 12n to the 3 halves. Third root of b squared. This is the same thing as b to the 2/3. And square root of 37 squared is 37 to the 5 halves. Now notice here how we couldn't simplify any of these variables or these numbers because they would just get kind of messy decimals. In the next section, we're going to actually simplify. So 49 to the 3 halves. Remember how we can rewrite this as 49 to the 1/2 cubed. So it's a little bit easier to take in. Well, we know 49 to the 1/2 is the same thing as the square root of 49, which is 7. So this simplifies to 7 cubed, which is 7 times 7 times 7, which is 343. 25 to the 3 halves. We can rewrite this as 25 to the 1/2 cubed, which is the same thing as the square root of 25 cubed, or 5 cubed, which gives us 5 times 5 times 5, or 125. 27 to the 2/3 is the same thing as 27 to the 1/3 squared. So here we can think about this as the cube root of 27 is 3. 3 squared gives us 9. And again, these become a lot easier with practice. You'll see kind of similar patterns occurring. 64 to the 2/3. This is the same thing as 64 to the 1/3 squared, which is 4 squared. 4 times 4, which gives us 16. 100 to the 3 halves. Now we know by this exponent here, it's going to be bigger than 100. Our answer will be bigger than 100. So this is the same thing as 100 to the 1/2 cubed. 100 to the 1/2 is the same thing as the square root of 100, which is 10. 10 cubed is 10 times 10 times 10, which is 1,000. 4th root of 16 cubed. So 4th root of 16, let's think about PEMDAS. That means a number times itself again, times itself again, gets you 16. So this is going to be 2 cubed, which gets you 8. And again, I'm showing it 2 different methods. Earlier in part 2, we did a lot with like the chocolate bar method. This is more, once you feel comfortable with the chocolate bar method, then you can kind of advance to this method. So square root of 144 squared. Now notice we talked about this actually in part 1. We know the square root has a root of 2. Now when we have a square root and it's raised to the 2nd power, they cancel each other out. So what we're left with is really just the number under a radical, which in this case is just 144. So they cancel out. Almost done. Cube root of 125 squared. So this is the same thing. Cube root of 125 is 5. 5 squared is 25. Last but not least, the square root of 64 squared. Very similar to before. This is the 2nd root of 64 squared. They cancel out. So we're just left with 64. So here they also cancel out. And your homework is quizzes topic 29, which is online. And thank you for watching.